So even before we get started with the clustering exercise, I wish to briefly discuss about data mining. Data mining is also called as machine learning, basically. Or rather, data mining supervised technique is called as machine learning. But any technique that you want to employ, you need some historical data. Right? That any uh, you know uh, technique or any prediction model, etc., that you want to do, you first need historical data to deal with that. And within this historical data, if we have the output variable, right, then it is called as supervised learning. So if within the historical data you know the output variable, then you go with supervised learning. For example, in your linear regression or logistic or Poisson, everything is part of your data mining techniques, right? So if you want to predict, I mean, we have already seen in simple linear regression, we wanted to predict the adipose tissue. So in the historical data, you had that adipose tissue value. And in multiple linear regression, we tried to predict miles per gallon. And in the historical data, you had that output variable which is known, right? That is when you proceed with supervised learning. And what is unsupervised learning? If the output variable y is unknown, then you proceed with unsupervised learning if you don't know the output variable. And clustering is an unsupervised learning technique. Yeah, so I'm just setting the context up front. All right. So what are the types of methods that we have? One is supervised learning. Another is unsupervised learning. Within supervised learning, again, you have two branches. Of course, in the historical data, you need to know what is a y, right? And if the output variable is numerical that you're trying to predict, it's called as prediction or regression technique. But if the output variable is categorical, yes, no, true, false, defective, not defective, so on and so forth, in such a scenario, you proceed with classification technique. So these are the two broad branches when it comes to data mining, supervised learning. And when it comes to unsupervised learning, you have segmentation or clustering, and these are the two techniques that we're going to discuss now. Of course, you have dimension reduction, relationship mining, which is also called as association rules or affinity analysis. You have recommendation system or collaborative filtering and network analysis. We'll discuss about all that moving forward. So let me proceed further. Yeah, so these are the things that we have discussed. As part of your supervised learning, these are the various classification techniques that we will be discussing. Yeah. All this slowly and steadily, we will be getting used to. And majority in the industry, majority of the models that you actually build are, cocktail models. That means the supervised learning techniques and unsupervised techniques, right, overlap. That is the norm of the day. So that is how you proceed further. So there are primarily two approaches to perform clustering when you have two variables or greater than two variables. One is compute multivariate distance between records and group closed records. So this technique is called as hierarchical clustering. And this technique where we group records to increase within group homogeneity is called as non-hierarchical clustering. All right. So these are the two techniques. Now first we will be spending some time on hierarchical clustering. So I'll discuss only about this. I will try to set the intuition behind, post which we will get started or continue with non-hierarchical clustering. So here, assume that each record that you have, each record is a cluster. For example, say you're trying to group different people together, say in a financial sector, say bank, you have 10,000 customers. You're trying to group all these 10,000 customers into different clusters or segments. Maybe all the people who are super affluent, such as Vijay Mallya, etc., you're grouping everyone together. Maybe you're trying to group the rest of the people who are not so affluent into another group. Maybe you tend to do that, right? But the logic here in hierarchical clustering is that all these 10,000 people, right, each one of these 10,000 people is considered to be one cluster. So you have those many clusters. So here the intuition is that you try to find out on how similar A is to B, how similar A is to C, how similar A is to D, how similar A is to E, and how similar is A to F. This is what you wish to cluster. And also you try to find out the similarity between B and C, B and D, B and E, B and F, and you try to find out the similarity between CD, CE, CF, and also you'll try to find out the similarities between DE and DF. Probably you'll also try to, not probably, you'll also try to find out the similarity between EF. Yeah, this is how it works basically. Now, based on that, we know for a fact that B and C are close to each other. You try to find out the distance basically. You try to find out the distance between each and two of these. And based on that, we know for a fact that B and C are close to each other. So you're going to group B and C. Now this B and C has become a group. It's no longer an individual record. It is called as a group. And also you found that D and E are similar to each other, so you form another group. And now you need to find out the distance between each individual record and a group. And also you need to find out the distance between this group and this group. You need to find out the distance between this group and this record. Assume that this distance between the group and the record is very close, then you're going to group these three together. And then you try to find out the distance between BC and DEF and each record and the group. Since the distance between these two groups is similar, you'll try to group these two together. And finally you have a single group. Right? Say there is person A who is staying 10 kilometers from the office, whose home is 10 kilometers from your office. There is another person B who stays 50 kilometers from your office. Who do you think is closer? Person A. Based on what? Based on distance. Right? That is how you try to relate the similarity. All right. So here, when it comes to hierarchical clustering, you need to find out the distance between one record to another record. That's the first thing, because each record is a cluster. Second, you need to find out the distance between each record and group. For example, you need to find out the distance between DE, which is a group, and F, which is a record. And on similar lines, you also might want to find out the distance between one group to another. So here you have one group, here you have another group, right? And you try to find out the similarity between different groups. These are the various ways, or these are the various these are the various distances that you need to calculate. All right.